So we're going to revisit our law of conservation of energy. And as our good friend Newton says over here, this is when our law of conservation of energy really intensifies. We start adding numbers and start thinking about what this means in terms of math. So recall, our law of conservation of energy says that energy can't be created, it can't be destroyed, it can only be transferred. And so what that means is that when we have a system that's gaining energy from the surrounding, it means that the surrounding is losing energy and vice versa. If the surrounding is gaining energy, the system is losing it. And so when something loses energy, we generally say that it's negative. Like when you lose money out of your bank account, it goes to the negative. So what we can say is that our energy gained is equal to our negative energy lost. And then we plug our formula back in. We have the mass of specific heat and the change in temperature equal to the negative mass of specific heat and temperature. So the way this works, we have a calorimeter. We have our unknown, or our known, usually it's an unknown. You heat it up to an unknown temperature. You have a known temperature of the water because you have a thermometer in the water. And the heat energy from that metal starts to radiate out into the water. And so the water starts to absorb the heat from the metal. And so we can record the temperature change in the water, and we can record the temperature change in the unknown. We can record the mass of the water, we can record the mass of the unknown. We know the specific heat of water, if we round it off, is 4 joules per gram Celsius. So at that point, we can just solve for whatever unknown we have and then look up what that specific heat value is in a table to figure out what it is. So if we try this out, we have 4.82 grams of an unknown metal is heated up to 115 grams Celsius and then placed in 35 mils of water at 28.7 degrees Celsius, and then is heated. The final temperature is 34.5 degrees Celsius. And we want to know what is the specific heat of the metal.
So when we break this down, we have an unknown mass, 4.82 grams. Its initial temperature is 115 degrees Celsius. And then it's in 35 mils of water, which we can say is 35 grams of water. The initial temperature of the water, 28.7. At the end of the reaction, both of them are at 34 degrees Celsius. And so the unknown, when we put that in the water, it was hot, and it's going to start losing its heat to the water, so it's Q lost. The water is going to start absorbing the heat coming off the metal, so it's going to be Q gain. We have our mass, specific heat and temperature on both sides, and we just plug everything in at this point. And we have negative mass of the unknown, we don't know C, final temperature minus the initial temperature is equal to our mass of the water. Our specific heat of water is 4 joules per gram. And our change in temperature, we have that final temperature minus the initial. And so when we multiply all of this out, we get 812. The grams and the gram cancel, the Celsius and the Celsius cancel, so we have 812 joules. And we subtract and multiply, we get 388, negative 388. 0.01 grams Celsius. And so these two negatives, they cancel out, so it just stays positive. So at this point, we just divide the two. So we put this on the bottom, that goes on top, and we get 2.09 joules per gram Celsius.
So we'll do one more example. We have 100 grams of water. We'll round off the specific heat of water to 4. Its initial temperature is 100 degrees Celsius. It's mixed with 50 grams of another liquid whose specific heat we don't know. But we do know its initial temperature is 30 degrees Celsius. And when we bring the two together, the final temperature is 50 degrees Celsius. We want to know the specific heat of the unknown liquid.
Alright, so we break this question down. It tells us that the mass of the water is 100 grams. It tells us the C, we're going to round that off to 4 joules per gram Celsius. The water is starting out at 100 degrees Celsius. It also tells us that a hot unknown is at 50 grams. We don't know what the specific heat is, we don't know what it is. But we do know it started out at 30, and the final temperature was 50. And so when we put that hot unknown in the water, it starts losing energy to the water who's gaining it. So the temperature of the water goes up and the temperature of the block goes down. So when we plug in these variables, we have our mass, our specific heat, and our change in temperature. I'll set that equal to negative. Mass, we don't know. C, change in temperature. So the T2 minus the T1. So when we multiply all this out, we get negative 20,000. This gram and that gram cancels. This Celsius and that Celsius cancels. So we're left with joules. On this side, we have 50 minus 30, we get 20 times 50. We have negative 1,000 GC times our unknown. We have grams, we have Celsius, so we're with GC. So at this point, we just divide negative by negative, we get a positive 20 joules per gram Celsius is our specific heat of the unknown.